First of all, welcome everybody and good morning. This is me, so it's a bit scary, so I hope you're all awake now. I work for Kumina. Kumina is a company specialized in managed operations, and we mainly target on large web clusters with lots and lots of machines. We do this using Debian and different versions from Debian. So I hope this gives you a little more understanding why we use Puppet. But of course I'll tell more about it during my presentation. Puppet is a product developed by a company called Reductive Labs. Credits to the people who deserve it. Luc Kees is one of the co-founders of Reductive Labs, and if you Google for information on Puppet, or if you read documentation about this, you'll probably read something about Luc. So all the nice things I'll talk about, Luc developed, and the credits are for Luc. Puppet. The TDOS guys asked me to save some time for questions and for maybe some discussion. I absolutely do not mind if you ask questions during my presentation. The only request I've got is just point your finger, and after the end of the sentence I'll ask what you have to ask. So please do ask questions. First of all, I'd like to give you some introduction. At Kumina, a few years ago, we had some challenges. First of all, we had scalability problems. The amount of servers we were administrating for our clients grew and grew and grew and grew. And when the amount of a few dozen servers was reached, it wasn't really necessary to think about the scalability problems. Imagine yourself a few-man crew, like 3 guys. It's quite doable to administer, for example, a 30 or a 40 servers with 3 guys. But wonder yourself, what will happen if this amount of servers is 100 or 200 or even larger? At some point, you won't be able to deliver quality, you won't be able to look into everything, and you won't be able to keep an overview anymore. Secondly, we wanted more automation, and we were looking for a product that could help us to automate stuff. Then I jump to the next thing, best practices. In the years we used Debian, we developed a lot of best practices, as in, judge for yourself, most people have some package they would like to use. For example, if you do not like the Vim editor, but the Joe editor, on every box you log in, you'll probably install the Joe package. I guess you can all imagine that. So we were looking for a tool that could help us to apply our best practices on each box we maintain. And therefore, we automatically get more and more consistency that also helps us to scale again, since when you're used to a box with a certain configuration and log in on another box and the configuration is very similar, you can do your work quicker. You do not need a lot of time to understand the other box. We needed a tool that could do more for us than just configuration. There are a lot of tools out there, for example, like Pi, fully automated installer, or CF Engine. that are able to configure your system during the installation, and the tools can help you to install some packages and to set some configuration files in /etc. But we needed a tool that could do more than that, and we needed support for multiple environments like staging, production, and development. We looked, we searched, and like I introduced, we found Puppet that fit best for us. But there's a lot of documentation out there about Puppet, but how does it work in real life? When we were looking for pragmatic examples, and when we were looking for other companies or schools or universities, whatever, we were looking for pragmatic examples. We were looking about stories about scalability and about we wanted to make sure the product is reliable, and we wanted to make sure the product does really work the way we expect it to do. So I thought it was a good idea to give a presentation about Puppet in real life, and all the technical stuff. You can Google it, you can find it on the Puppet wiki. I haven't got a clue about your background as audience, so if you want me to dig deeper, or if you want me to show some code examples and stuff like that, I brought all our code repository, so if you say, come on, this is too high level, just shout and I'll dig deeper. Alright? Is there anyone in the room who is not familiar with Puppet at all? Okay. That's what the quick introduction is all about. I'll start with that. Then I'll talk a little about how we use Puppet at Kumina. I'll talk about environments, how we organize our code base using version control. Almost last, I'll talk a little about performance. If you'll start to use Puppet, you'll probably visit the same pitfalls as we did, so I hope to save you that one. And I want to talk a little about community development, since of course we're at an open source convention, and of course Puppet is open source as well, and we believe that the Puppet stuff companies build should be open source as well. If there's anything I might miss, or something else you want to hear about Puppet, then this is the time. No? Alright? Okay. This is a little schematic view from Puppet. Puppet works using a client-server model. The Puppet master daemon is the master, hence the name of course. And in the Puppet master daemon you can save all the configuration you want to apply on your clients or puppets or nodes. The terms are used, client, puppet or node is exactly the same. All communication between the Puppet master and the clients uses HTTP with SSL, using an XML RPC mechanism at this moment. I believe the Puppet programmers are trying to use another protocol in the near future, but at this moment it's XML RPC stuff. Each client runs a Ruby-based piece of software, the Puppet client, and by default each Puppet client connects each half hour to the Puppet master, and it asks, hello, I'm there, have you got some configuration catalog for me? Well, then the Puppet master tries to compile the configuration you made, and then sends back via RPC over SSL the config to the client.